path algorithm. So before learning the shortest path algorithm, I'll suggest let's understand what is the shortest path in a graph. So before we dive into topic, let's first understand what is the shortest path is, and after that we will discuss why learning its algorithm is important. What is the shortest path? The shortest path means the path between two nodes, right? Means let's suppose we have given this unweighted graph, right? So we have given this unweighted graph, and let's suppose we have this is source and this is your target, right? So if I want to go to find the shortest path, means the shortest path means the path between two nodes, let's suppose source and target, right, in the graph, and that has the smallest possible total weight or cost among all the available paths, right? So in this case, let's suppose if nothing is given, there is a by default one will consider its distance, right, like this. So the one path can be like this, we can go directly like this and then we can reach here, right? Another path can be like this, it will go like this and then we can reach here, right? Or we can directly come like this and we can reach here, right? Means if the weight is given, then it is difficult, but if it is weight is not given, there can be multiple paths, right? Even if the weight is also given, there will be multiple paths where we have to find the minimum path that we have in the between the two nodes, you can say, right? Means we have to find the smallest possible total weight or total cost, you can say, among all the available path, right? So this is the concept that is widely used in the graph theory, and it plays a crucial role in various in solving various real world problem, you can say, right? Such as network routing, navigation system, and optimization challenges, you can say. If there is a optimization thing and you have to do solving the problem, right, that there it also come the shortest path, right? So for example, if we want to find the shortest path in the graph, like let's suppose vertex, this is a source vertex and this is and target vertex, right? So we need to explore all the possible path and we have to find it, right? So so what I'm trying to say, give me 1 second. Now let's understand let's understand in this picture, right? Like you do not need to find the weight or something else, right? You can say cost, right? But the graph consists of, you can see here a number of nodes and vertices, right? Nodes means vertices, like suppose this is given a source, there will be some value will be 1 to something like this. So if some value is there, right, let's suppose in the weighted graph like this, right, we have some weight we have given, right? Still there will be some value, let's suppose will be this is the some node value, right? This is the node value is there. So if there is, let's suppose either write a b c d like this, we can write, right? So these a b c d is nothing but what, this is your nodes, or you can say vertices, and it is connecting with this edges, right? And so two nodes or vertices is connected by edges. That is, you already aware with the graph terminology, right? So edges can have weight or cost, which typically represent distance, time, or other measurable metrics, you can say, right? Like in this case we have given weight, sometimes it can be a time from a to b. If there is a nodes given a and b, so if you want to travel through from a to b, the times will be there, that is also given, or other metrics we also may have given, right? So the other possible graphs are the other possible graphs that can be used to find the shortest path are, like we have weighted graph, right? Then we have unweighted graph, and then negative weight graph. So the negative weight graph is used for the Bellman-Ford graph, right? So let's first understand the unweighted graph. What is unweighted graph, right? As you can see in this picture, there is no weight given on the edge, right? Let me clean this so you will understand. Now you can see, right? So there is no weight we have given in this graph, right? And all the vertices are connected with each other, right? So An unweighted graph means that no weight, or you can say cost, is assigned to the a's, right? No, nothing is there. So in this picture of graph, we can see that no weight or cost we have given for the a's, right? Or any a's, you can say. Now the question is, how do we find the distance between two nodes if the weight or cost is not given, right? Means I am talking about, let's suppose this is your source, right? From here and from to here. So how we are going to find the you can say distance, right? Between two nodes, either you can say from here and to here also. Let's suppose if this is a vertices or node and this is b, right? So from a to b, if somebody want to find the distance, how will you find that, right? If the weight is not given, right? So what is the weight or cost of the a's in unweighted graph, right? This is very important question. See, if you will not logically ask your questions yourself to right, then you, how will you understand the concept, right? So if this type of things is coming right on the topic that what is unweighted graph and how we are going to find if weight is not given, then your mind start logically getting asked to you, that it will ask to you that what is the meaning of that, right? Means what is the weight, what is the cost of the a's, right? If the, in the unweighted graph, then you will try to understand the lead core problems. Because see, theoretically we have to understand, then you have to find the question, right? Because see, I have uploaded many questions, and some of the questions I found the you can say comment from the viewers, that they are saying I'm not understanding what you are saying, I do not understand the solution and those. So sometimes I'm thinking maybe there is a gap you have, and need, I do not want to explain all the time, because you in the comment you go so somebody may feel egoistic that I'm writing the question, I'm not understanding, and those things. So I want to the regular viewer, that you, if you are watching this video, means you are a regular viewer, and you will consistently see the theoretical question as well as the practical questions. I'll keep updating theoretical and practical questions as well, right? So try to gather both topics so that you will have the concept. Okay, so back to the problem, right? What is the weight or cost of edges in an unweighted graph, right? So without weight or cost, it would not be possible to find the distance between two nodes. By default, we consider the weight or cost of edges in an unweighted graph to be 1. It means if we want to find from the distance from A to B, right, there should be something, right? So that we can say there is a distance, right, between these two nodes, right? But without weight or cost, it would not be possible to find the distance between these two nodes, right? So by default, what we do, we consider the weight or cost of these two, the age you can say, in unweighted graph as a 1, right? By default, we'll consider as a 1. So this means the distance between these two neighboring nodes, right, is treated as 1, right? And so if you'll come by default, if you'll put all ones right here, means from here to here it will count 1 1 2 and 2 3. From here to here it will come 3, right? If somebody want to go from here also, right, it means what, it will become what, 1 2 3 4, but minimum distance is what, 3, right? Means you have to provide the minimum weight, that you have, you can say, or cost is 1, right? And then you can say okay, so the by default if you'll provide, then we can find the weight, right? Now consider this give me 1 second, let me clean this. Okay, so next we have the weighted graph, right? So the weighted graph means that each edge that we have given is assigned a specific weight or cost, right? So you can see we have given 71632, right? So this is the weight of each edge, or you can say cost of each edge, we can say we have given, right? So in this picture of graph, we can see that the weight or cost are given for the edges, right? If edges we have some weight, right, or cost, you can say. So that the what is the significance of weight or cost in the weighted graph, right? If we have given the weight or cost in the graph. So what is the significance, what is the thing, right? So as you told in the previous questions, right, previous one, that without the weight, how you will find the weight, the distance, right? The same way we can say the significance of weight or cost in a weighted graph is very important, because with these weight or cost that represent distance, cost, or any other matrix between the two connected nodes, right, we will use the weight to find the exact distance or cost between these, right? So uh, we have to calculate 7 plus 1 plus 2, right, like that. We have to consider this one, and then we can say we will find the exact distance, right? So the presence of weight in the graph makes an easy choice to choose the path, and so it enables more complex operations such as finding the shortest path, right? Now we have negative weighted graph, and that is nothing but the Bellman-Ford algorithms, right? So in the Bellman-Ford algorithm, you can see we have given -8, 1, -9, and 2 and 3, right? So the negative weighted graph means that some edges are assigned negative weight or cost, right? So the weight or cost can be negative weight, and so in this picture we can see that the certain edges have negative weights, right? Means -8, -9, as you can see here, right? We have given sorry, give me a second. Okay, so this given -8 is given and -9 is given as a negative weight, right? So what is the significance of this negative weight in the graph, right? Means negative weight can represent scenarios such as discount, you can say, penalty, reduction in the cost, right? So however you can say they can also lead to a complexities in the finding the shortest path, as you may heard of cycle with a negative weight, right? So if the cycle with the negative weight may result in infinite reduction, if you keep updating minus minus minus, then what will happen? It will lead to infinite things, right? Reduction, you can say. So the Bellman-Ford algorithm is especially designed to handle the you can say graph with the negative weights, right? And that is why I have mentioned here the Bellman-Ford algorithm here, right? And so the Bellman-Ford algorithm is especially designed to handle this graph with the negative weights, right? So the Bellman-Ford also help to compute the shortest path from source node to all other nodes, even in the negative we have given or not, it will handle. So if there is negative, you must try to solve with the Bellman-Ford, because the weights are given negative. If there is no negative weight cycle, means it's also fine. Okay, so now you have covered everything, right? Almost everything you have covered, all the weighted and these things. So let's understand some key point, right? So you will understand. Okay, what happened? Okay, so coming back to the shortest path algorithm, right? So what is the key point we have to understand in this section, right? So weighted graph can have both negative and non-negative, right? But the unweighted graph will do not have any weight and cost, right? So why do negative and non-negative weights in the weighted graph, right? Because see, if non-negative weights we have given, means 0 or some positive value will are given, right? So 0, or you can say any positive numbers. So non-negative weights are very common, right? So if we talk about the non-negative weights that represent metrics in the graph, like distance, cost, and time, those things, right? On the other hand, if we have negative weights, means it is used like some scenario, like you can say decrease of benefits such as discount, reduction, that we have given. In that time, the application will say. So whenever you are writing the solving the related problem, right, and that time you have to understand is there any discount is given, any reduction is given, right? So if there is a scenario is coming to decrease or benefit, right, in such cases you have to understand that there must be a negative weight, and in that case you have to use the Bellman-Ford algorithm, right? So while the graph with the non-negative weights are easier to solve the problem with the algorithm like this algorithm, in that case you will use the etc. But when the presence of negative weights we have given, right, then that time we have to use the Bellman-Ford algorithm. So the main algorithm can compute the both shortest path. The main aim of the algorithm is to compute the shortest path, right? even we have the negative or not, we have the negative. So you have to find out this etc we will use or Bellman-Ford we will use, right? So we'll also see some problem based on other shortest path algorithms, right? So in the next video we'll understand shortest single source shortest path algorithm, right? If you have already aware with that, or you have already seen my other videos of theoretical, then you will understand these things. And we'll also understand single pair shortest path algorithm, right? Like that we will use all the topics, and we'll cover the type of shortest path, and then we'll continue to solve the problem, right? Okay, I'll see you the next one. Thank you guys.
Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel and